Newton's third law of motion. If one object exerts force on another object, then the second object exerts force of equal strength in opposite direction of the first object. Put it simply, for every action there is an equal but opposite reaction. And so here we have action-reaction pairs. The first is a balloon, right? If you have a balloon full of oxygen or air and you let go of the balloon, the air pushes down, which forces the balloon to go up. So they have like opposite reactions. Same with if you push on your desk, like if you push down on your desk, the desk is actually pushing back up against you, and that is the action-reaction. Because if you push down and your hands went through the desk, there would be no force, but as it is, your hands don't go through your desk, thankfully. And so the desk is pushing back against you. So you can try it. You can feel it. It's like pushing back against you. And so those are called normal forces. This is how rockets work, right? So they expel gas down. It's kind of like our stomp rockets last year. You guys stomped on the 2-liter bottle, and that forced the air to go through. And so it was leaving one place and going to another. So action, reaction. If two people of same mass were on a skateboard and they both pushed off of each other, they would have this kind of a thing. And so I found this video, and I'm going to just play it because I don't know if YouTube will block it or not for you guys. So I'd rather you get to see it than not.
Welcome to the International Space Station. I'm NASA astronaut Mark Vande Hei. Today, we're going to talk about Newton's third law. How do you think it will hold up in microgravity?
For every action, there is an equal and opposite reaction. This means that in every interaction between two objects, there are a pair of opposite forces acting on each object at the same time. A force pair. You can see that there are many examples on Earth. In space, thrusters expel one way and the vehicle is steered in the opposite way.
Hello again. More basketball stunts that I can't do on the ground. At least not while getting this much hang time. Alright, back to serious business. Got a basketball right here. There'd be object 1. I'm the second object. If object 2, myself, applies a force to object 1, then that same force will be applied according to Newton's third law by object 1 onto object 2. However, there's a big disparity in the mass. Object 1 is a very light mass object. Object 2, myself, is a larger mass object. So, I'm going to try to make myself about the same shape as this ball. See how that works for us. And I'm going to apply that force. Saw that force applied to the ball made it accelerate quite a bit. It really didn't accelerate me much at all. Newton's third law again, but this time we're going to use two similarly massed objects. Joe and I have about the same mass, so Joe get into a ball, I'll do the same. I'm going to face you this way so I don't throw you into something you can't see. Now I'm going to get into a ball behind Joe, and I'm going to apply a force to him. Notice that when I applied a force to Joe, it accelerated Joe away from me, but I got accelerated away from him as well, because the force applied to Joe ended up being the same force that was applied to me. Now you've seen Newton's third law in space. Now test it out on Earth. See you next time.